Hi, I'm going to give you a quick demonstration on WAM3d's new heavy metal calculator. After acquiring your data from your balancer, input it into each plane into the program. So let's say if our left plane data on the balancer acquired a radius of 2.5 inches was 355 grams, and we're working with a 1.2 inch counterweight, and we're going to be using 1 inch diameter heavy metal, and the spacing between our slugs would be 125 thousandths. Then our installation would be 3 slugs, which would weigh in on the scales at 424 grams. We'd have a 7% or 28 gram angular loss. So how the weight would affect the balance, it would actually look like 396 grams. Now the good news is we have an overcorrection of 41 grams on this plane, which is really good. So now we'd go into our right plane information, and let's say that's 300 grams. Okay, 2.5 inch radius, 1.2 inch counterweight, 1 inch slug. That's 3 slugs weighing in at 424 with a 97 gram overcorrection. Now these planes are right now correct, and if you looked at this, there would be 3 slugs. Here's your layout for the right plane, layout for the left plane, and everything looks good. Now the 41 grams holds true unless you do the other plane. So once you install the metal in the left plane, it is 41 grams heavy. Once you go in and do the right plane, even though that's showing 97 grams heavy, there's going to be crosstalk and an effect that's going to change the balance. So if we'd like to know what that effect is, we would now combine these planes. And this control gives us the ability to make that calculation. So basically, if our planes are together, if all the center line of the heavy metal that we're putting in on the front and the rear counterweight, the counterweights were on the same side, then we would have a situation like this where they are lined up, they are in phase. If they were typically 180 degrees apart, like they are on a V8 crankshaft, then we would use this setting. So we're going to go with 120 on this, because this is how our slug alignment is for this particular demo. So with the planes combined, you know, one of the peculiarities of heavy metal installation is the more that you put in, the less it actually affects balance. So if you had a crankshaft that needed 700 grams, let's say you had campground counterweights, you spun it up and it needed 700 grams. The question is, can you do it? And that's kind of a nice feature that this has. It's a trial weight feature. So you can go in and put 700 grams under the current parameters, and if you look in the red, you've made an undercorrection of 128. Test to determine if increasing a rate weight with current parameters can correct negative grams. So just hit the test button, and even with 7 slugs, it's still 67 grams light. So instead of getting halfway through the job and finding out that regardless of how much metal you put in, you can't balance the crank, you'll know this beforehand. So you can either go and click install in the second counterweight, and that would be a good solution, or else you can increase your heavy metal diameter to, say, 1 in 250. So these are just a few of the features of WAM3d, and this calculator is a pretty nifty addition to the program. I thank you very much for your time, and good luck in your heavy metal endeavors. Thank you.